Good morning, dear students. Okay, let's start. Today, last time we discussed with you linear kinematics. Today, I'm going to start dynamics. But before going to dynamics, if you have some questions concerning kinematics, linear kinematics, you can ask now. I answer your questions and solve your problems and then move further. Or if you don't have questions yet, but if you will have questions later, you can write them on our Telegram channel. Okay, now we start dynamics. Dynamics is based on Newton's laws of motion. So our topic is dynamics, Newton's law of motion. Let's remember Newton's three laws of motion. First law. First law is about inertia. This is called the law of inertia. So imagine that we have a body and no forces acting to that body, or forces acting to that body is compensated. For example, if several forces act to the body, but their vector sum is 0, then this body will remain stationary or moves with constant speed. This is Newton's first law. So if force equal to 0, the net force is equal to 0, then so if net force is equal to 0, then acceleration is also 0. This is Newton's first law, mathematical form of Newton's first law. That means if no force acting to the body, or the forces are compensated, for example, we have weight force acting down. This is mg, the weight force. And we have reaction force of the surface. If the body is at the surface, some surface, it has reaction force. So you are sitting in the table, you are sitting in the chair, on the chair, and two forces acting to you, downwards it's weight, and upwards it's a reaction of the chair. Yes. And they are compensated. They are equal to each other. That's why the net force is equal to 0. And according to the Newton's first law, if reaction net force is equal to 0, then acceleration is 0. So you have no acceleration. You have no motion. You were stationary at the beginning, you remain stationary. Another example, if you have, imagine that there is a rocket in the free space. So there is no other objects around. The rocket is moving in the outer space, far from the planet, far from the Earth and other planets, other stars. Imagine that in the free space, this is a rocket. There is no forces acting to this rocket. And this rocket moves in some direction. And it has a speed. It has initial speed, and then if all the engines, all the reactive engines are switched off, no forces acting to the rocket, then it has inertia. It moves with inertia. That means no reaction force, no air resistance, because it's in the vacuum, in the free space. No planets, no gravity. It moves with constant speed, without any engine, without any fuel. It remains moving with constant speed. This is due to the Newton's first law. So the net force is zero, no forces acting on the rocket. Acceleration is zero. So acceleration is zero means its velocity doesn't change during the motion. If it has some velocity v, then this velocity keeps constant. Velocity v. This is another example of Newton's first law. Now, second law. Second law is most general law among the Newton's laws. So if the net force is not zero, imagine that the sum of all forces is not zero. If F net is not zero, then acceleration also will not be zero. Acceleration will be equal to, is directly proportional to, so acceleration is vector, is directly proportional to the force. Force is also vector, and inversely proportional to the mass of the body. This is Newton's second law. A equals F divided by M. Or another form of this Newton's law is the force. If you find force from here, force equals to mass multiplied by acceleration. This is two different forms, but the same equation. It means that if net force is not zero, this is net force, of course. This is net force. And this is also net force. What is net force? I think you know. Net force is the sum of all forces, the vector sum of all forces acting to the body. In mathematics, we have this symbol, sigma, which means the sum of all forces, the sum of all elements, Fi. This means F1 plus F2, all vectors. F is vector. This sum means F1 vector, F1 vector, plus F2 vector, plus F3 vector, etc. So pay attention to that. This is not algebraic sum, but the geometric sum, the vector sum. How to add vectors? I think you know. In order to add vectors, we have two rules. First one is called the triangle rule. If we have force vector 1, force F1, and vector 2, this is vector F1, and we have vector 2. For example, this vector. We have two vectors. In order to add these two vectors,
Нет. Меня не слышно вообще там?
okay, if we have two vectors, the addition of these two vectors This is called triangle rule. We draw the triangle here. So we connect the end of the first vector with the beginning of the second vector. Then the sum of these two vectors is, we connect, we draw a triangle, we connect the beginning of the first vector with the end of the second vector. So this orange is the sum of these two vectors, black and blue. This is called triangle rule. And another rule is called parallelogram rule. In parallelogram rule, in order to add vectors, if we have two vectors, vector 1 and vector 2, okay, let's do with the same vectors. We have the same vectors, same vector, blue vector is the same, you can compare, they are the same. And let's do this, the same vector. This is the same vector, but we are going to add them with parallelogram rule. We connect their beginnings. We connect, let's check, is it the same vector? Or a little bit distorted. Okay, now they are the same vectors, and when we add them via parallelogram rule, you should draw the parallelogram. Parallelogram means you draw parallel lines to these two vectors. We draw the first parallel line here. You should make it parallel to the first vector. And another line also parallel to the second vector. And you have to draw the diagonal of this parallelogram. And the diagonal of this parallelogram will be the sum vector. This is the diagonal of these two diagonal of this parallelogram. Now let's check this sum vector is the same with initial. Yes, they are the same. You can see the two methods gives you the same results. Depends on you. If you like the triangle method, you use triangle method. If you like parallelogram method, you can do parallelogram method. This is how you add these vectors f1, f2, f3, etc. But if you want, this is geometrical way of adding vectors. If you want to do the exact numerical value, if you want to find the exact value of these vectors, then you have to use the cosine theorem. So this is, by this way you can draw it geometrically, and you find it geometrically. So if the values are given, for example, okay, let's do the following. This is our vector f1, f1, this is our vector f1, and this is our vector f2, f2, and this is the orange one is fnet. And how to find them? How they are related with each other? We have to know this angle between two vectors in order to find the fnet vector. So we should know what is the angle between f1 and f2. Let's say here we have an angle theta, let's say this is angle theta. Angle between two vectors is theta. Then we can write cosine theorem, theorem of cosine, that f net square is equal to f1 square plus f2 square minus 2 f1 f2 cosine theta. This is cosine theorem. And if you know f1, f2 and angle theta, so f1, f2 and angle theta, you can calculate by using this formula the net force. This is one way. If we have two vectors, this way is very simple. If you have more than two vectors, what then you should do? So another way is to make the vectors, add the components of vectors. Each vector can be written in Cartesian system of coordinates. For example, vector f net or vector f1 or vector f2 can be written in the components so any vector f can be written as fx unit vector I plus fy unit vector j. What is this I and j? I think you know from algebra, these ij vectors are called unit vectors. For example, if we consider f net, this net force, or f1, vector f1, let's consider this vector f2, for example. So what is its components? X and y components. So this is x-axis, horizontal x-axis, and vertical is y-axis. This is y-axis, and we can find its projections to x and y coordinates. This is projections of this vector. Projection. So, and what are components? This is x component of a vector and y component of a vector. So x and y components. This is f in diagonal. This is fx and this is fy. And I and j are unit vectors. I is unit vector along x-axis and j is unit vector along y-axis. So we can decompose each vector to its components by using the formula. We can use the formula in order to find the components of a vectors. So fx is f cosine theta. Theta is angle between the vector and x-axis. And fy can be found by using f sine theta. This is y component of a vector. And then after decomposing each vector to its x and y components, you can add every component separately. For example, you find x component of f1, x component of f2, then you add these x components, you get x component of fnet. The similar thing you can write for y component. And at the end, you use Pythagoras theorem in order to find f, magnitude of f. Okay, we discuss in some examples, and it will be clear after solving some problems. So after finding net force, you divide net force by the mass of the body, you get acceleration. And now after finding acceleration, the problem becomes kinematics problem. So after writing Newton's second law, the problem becomes kinematics. So what does it mean? It means that you can find acceleration by using Newton's second law. Then you write so you should know all the forces acting to the body, all the forces. It's the first step to solve dynamics problems. Second, add all the forces. And the third step, so add the forces to find net force. So I explained how to add forces with the vector additions. And the third step, write down Newton's second law and find acceleration. The fourth step is, after finding acceleration, the problem becomes kinematics problem. Kinematics problem you know how to solve from previous lessons. For example, if A is given, A of t is given, you can find V of t by integrating, if you remember previous lesson. And again, integrating, you will get x of t. So main problem of the physics of kinematics or mechanics or dynamics is to find x of t. How body moves, how its coordinate or its position change with time. So this is the algorithm of the solution of dynamics problem. Okay, let's apply this algorithm to solve some problem in dynamics. We start with the easier ones. Okay, any problem we can take. Okay, let's do this number 60. "70 Newton block and 35 Newton block are connected by a string as shown. If the pulley is massless and the surface is frictionless, the magnitude of the acceleration of 35 Newton block is..." So we have to find the acceleration of the 35 Newton block. Okay, let's start with the first step. Find all the forces. So we have to write all the forces. What kind of forces acts on the body? So the first force is the weight of the bodies. The weight of the 70 Newton is greater. Let's draw it like this. This is 70 Newton force, weight of the first body. Second force is the weight of the 35 Newton body. This is smaller, 35 Newtons. Now, what about other forces? We have reaction force of the surface, reaction of the surface, reaction of the table here. And also we have the tension of the rope. This is rope and it has a tension force. Let's draw the tension force. This is tension force. And also tension force acts from two ends. Remember that if you have some rope, this kind of rope, and when you stretch this rope, the rope tries to shrink down in the direction of opposite to the stretch. So from this end, the tension force acts on to the rightwards, and from another end, the tension force acts to the leftwards. Remember this about the ropes. So from this end, it tries to compress in this direction, and from this end in this direction. Always remember this picture when you draw the direction of tension forces. So if you draw it like this, it will be incorrect in opposite direction. For example, like this, it's incorrect. That's why I always draw it like this.
Hozir biza mamnun oldik-ku, mana bilan. Hozir. Mana bilan mamnun oldik-ku.
Yo'q, bu mana hozir mana shu ikkita jismga ta'sir qilayotgan hamma kuchlarni yozib chiqyapmiz. Mana shu 70 newtonli jismga va 35 newtonli jismga ta'sir qilayotgan kuchlarni chizyapman. Okay. The second step is to add all the forces to find net force. So we have two bodies, 70 Newton and 35 Newton. That's why we have two accelerations. So we have two bodies. We can apply this algorithm for two bodies. Let's apply this algorithm for the 70 Newton body and then for 35 Newton body. For you to understand, I find everything. Here, the acceleration of the 35 Newton is asked, but I explain acceleration of the 70 Newton body also. So let's add all the forces to find net force on 70 Newton body. So this is body doesn't move in the vertical direction. It doesn't go down or it doesn't move up. That's why, according to the Newton's first law, in the vertical direction, the net force should be zero because there is no motion along vertical direction. And net force is zero means this 70 Newton force, weight, and this reaction force should be equal to each other. If two vectors are equal to each other, their sum, if you are going to find their sum by using either triangle method or parallelogram method, then you get that their sum is zero. So when you connect their ends, you should get zero resulting force. So that's why we can neglect these two forces. Their sum is zero. And only remaining force will be this force, the tension force. Let's note it as T. This is tension T. Okay? Then if one tension from the one end is T, then from the other end also will be T, because this is ideal rope. We assume that the rope is ideal. It has no mass, it's unstretchable, uncompressible, etc. So tensions from two ends will be equal to each other. That means this tension is also equal to T. This is also T. Okay. And because these two bodies are connected by the rope, they will have the same acceleration. Acceleration of the first body will be equal to acceleration of the second body. And that's why let's note it with the letter A, because all of them are equal to each other. And next step is to write down the Newton's second law. Newton's second law for the first body is T equals m1 multiplied by A1. A1 is A. What about Newton's second law for the second body? We have two forces here, mg is 35 newtons. Let's note it as weight W minus tension. Why minus? Because this body moves down, and that's why this force will be greater than tension force. That's why we subtract weight minus tension in order to find the net force. This is the net force equals M2A. So if it's 70 newtons, then it's approximately 7 kilograms, because weight equals mg. So mass of the first is weight of the first divided by g. It's 70 divided by 9.8. Let's approximate it by 10. Then you get 7, approximately 7 kilograms. In the same way, mass of the second is weight of the second divided by g. It's also approximately 3.5 kilograms, because it's 35 newtons divided by 10 is 3.5. Then we have to solve the system of equations. Okay, we have to solve the system of equations. These two equations, system of these two equations. And find the acceleration from this equation. So how to solve this system of these two equations? So to solve this system of equations, the idea is to substitute t here. Substitute t, then substitute the first equation to the second, then we get w minus m1a equals m2a. Then from this equation we can find acceleration. Acceleration will be w divided by m1 plus m2. W is 35. This is actually W2 because we wrote it for the second body. This is W2 actually, because it comes from the second equation, and second equation is for the second body. So 35 divided by the sum of the masses 10.5. 3.5 plus 7 is 10.5. And we get 10 over 3, 3.33 meters per second square. Okay, this is the final result. So both accelerations of the first and second body will be equal to 3.33 meters per second square. Answer is B, 3.3. Do you have any questions? By the way, can you hear me now? Okay, let's move to another problem. Number 66. Three blocks ABC, each having mass m, are connected by strings as shown. Block C is pulled to the right by a force F that causes the entire system to accelerate. Neglecting the friction, the net force acting on the block is acting on the block B. Again, we use our algorithm to solve this problem. This is our algorithm. Let's use our algorithm. The first step is write down all the forces acting on all the bodies. So we are interested in the horizontal motion of this system. So we don't interested on the vertical motion of this system. And also weight forces of each block will be compensated by reaction forces towards up. That's why, so MAG is compensated with NA, MBG is compensated with NB, and MCG is compensated with that's why we don't write vertical forces. Let's concentrate only on horizontal forces. So let's write the horizontal forces acting on each body. So there is no friction, neglecting the friction. If no friction, then only tension forces acts on each body. So we have two strings. They are connected by strings. We have two strings, and that's why we have two tension forces. Let's note it T1 here and T2 here. Let's note them as T1 and T2. Let's note here tension as T1 is T1, and T2. This is T2. Okay. And so, what is the direction of these forces, T1 and T2? So, this is impossible to see here, but I'll try to draw the forces. Remember this diagram about the direction of tension forces. We have two ends of each rope. We have tension T1 acting to the body A to the right, and we have T1 acting to the body B to the left. I'll try to draw it like this. So this is T1. So T1 acts to the body A to the right, and T1 acts to the body B to the left. And the same thing can be drawn for force T2. So tension T2 acts to the body B to the right and to the body C to the left. This is tension T2. And also force F acts only on the body C. These are all the forces acting on the horizontal direction. As I mentioned before, I don't consider forces along vertical directions because they are balanced with each other. Now the second step, add all the forces to find net force. We have three bodies, that's why we have three net forces. Let's find the net force acting on the body A. I note it as FA. This is net force acting on the body A. It has only one force T1. So only one force acts on the body A, it's T1, this force. Net force acting on the body B. Two forces acting on the body B. This is T1 to the left and T2 to the right. We have x-axis. Let's assume that x-axis is directed to the rightwards. This is x-axis. That's why in the direction of x-axis, the force is positive. In the opposite direction of the x-axis, the force is negative. So T2 is positive. This T2 force acting to the body B is positive. T2. And this force T1 acting to the body B is negative, minus T1. This is net force acting to the body B. And net force acting to the body C is we have two forces, F and T2. F is positive and T2 is negative because it's opposite. This is T2 acting to the body C is negative. Sorry, T2. So we did the second step, add all the forces to find net force. We have three net forces, Fa, Fb, Fc. And then step 3 is write down Newton's second law and find acceleration. So we have three bodies, we have 3 Newton's laws, and we have Newton's second laws, and we have 3 accelerations. Let's write 3 accelerations with using Newton's second law. So acceleration of body A, according to the Newton's second law, is Fa divided by mass of the body A. This is Newton's second law. The same thing can be written for the bodies B and C. Now, what is Fa? Fa is T1. Let's write it. What is Fb? Fb is T2 minus T1. And Fc is F minus T2. So we did the third step. We write down the Newton's second law for all 3 bodies and found all 3 accelerations. So what was the question? Question was is to find the net force acting on the block B. So net force acting to the block B is T2 minus T1, but we don't know T2 minus T1. We know only F and we know only masses. So it's written that each having mass m. So all the masses are equal to each other. So that's why we can write here that ma is equal to m, mb is also equal to m, mc is also equal to m. And another thing which is not written here, but you should think about that by yourself, that all the 3 bodies are connected with the rope, with the string, and that's why they have the same accelerations. So this you should conclude by yourself. So that means accelerations A equal to acceleration of the B is equal to acceleration of the C. This is important. let's use this fact. Acceleration of the B is equal to acceleration of the C. And also let's note them as A because all of them are the same. So all of them are equal to A. Then we have to solve this system of equations. This system, 4 equations. How to solve this system of equations and find net force FB. So in order to find FB, we should find T1 and T2. So let's find tensions T1 and T2 from this system of equations. Before that, we have to find accelerations. Or we can write Newton's second law in another form, like T1 equals, from the first equation we can write T1 equals ma. This is from here. T1 is equal to m multiplied by a. And from here, from the second equation, we can write that T2 minus T1 is equal to also ma. So T2 minus T1 is m multiplied by a. And from the third equation, F minus T2 is equal to ma. F minus T2 is equal to ma. So now it's easy to solve it because we can add them now. Now we have a system of 3 equations. When we add these equations, these T1 and this T1 cancels out, and this T2 and this T2 also cancels out, and we get F equals 3ma. Because T1 minus T1 cancels out, T2 minus T2 cancels out, and on the left only F remains. On the right we have ma plus ma plus ma. We have 3 ma's. And then finally we can find acceleration from the last equation. Acceleration is force divided by 3 mass. This is acceleration of A. Now we can find tension T1 from this equation. So we know what is A, F divided by 3m. Substitute A to here, then you get F divided by 3 because m cancels out. Tension 2 you can find from either from the third equation or from the second equation. Okay, let's find it from the third equation. We move minus T2 to the right hand side with plus sign. We move ma to the left hand side with minus sign. Then we get tension 2 is equal to F minus ma. F minus A is given here. And when you substitute A to here, m cancels out, you get F over 3. And F minus F over 3 is 2F over 3. 2F over 3. This is T2. So we found tension 1 and tension 2. Tension 1 is F over 3, and tension 2 is 2F over 3. And FB is tension 2 minus tension 1. Let's find FB. Two F over 3 minus F over 3. Then we get F over 3. So net force acting to the body B is F over 3. Let's see the answer. Yes, it's answer B is F over 3. So I solved this problem with explanations, but here is the test for 1 or 2 minutes. You should solve this test during 1 or 2 minutes, but how to do that in the very short time? I give you the hint to solve this kind of problems very quickly. So first you draw this table, this diagram on your notebook, on your text script. So the quickest way is to think that this system is the one whole system. So it's not consist of 3 parts A, B, C, but you think that this system consists of combined masses with mass M, 3M. Total mass is 3M, and these internal forces T1 and T2 are internal forces. So we don't consider the internal forces. That's because if you consider the whole system, then the addition of these two forces will be neglected. These two forces will be cancel each other, these also. And you consider only the external forces F. So problem becomes very simple. So you can write Newton's second law for the whole system. So the external force, the net force, will be equal to F for the whole system, because internal forces T1 and T2 are cancelled. And the mass of the whole system is 3m. And acceleration of the whole system is a. So we reached this step very quickly with this equation. In the first method, we did it by solving the system of equations, but after understanding that method, now you can easily understand the second method. And from here, you can quickly find acceleration, as we did here. F divided by 3m. After finding the acceleration, you can write down the Newton's second law. Now you think again that this system is separately consists of these 3 parts, and write down Newton's second law for the part B as like this. So you write down these 3 equations then, and find T1 and T2, and then find the net force. Or you may think that acceleration is 3ma if all the masses are equal to each other. 3ma. Now this tension, so F is 3ma, so tension 2 is 2ma, because it accelerates 2m, and tension 1 is 1ma. So this tension 1 is MA, you see. Tension 2 is 2MA. This is 2MA. And FB is 2MA minus MA. Again, it's equal to MA. And A is F over 3M, then you get F over 3. The answer is F over 3. This is the quickest way to solve this problem. If you have some questions, please ask. If everything is clear, we continue next time. Maybe we continue dynamics with using of friction forces. Continue to solving problems like from this file, and next time, if you will have some questions, please ask, or during so our next lesson will be on Wednesday, 9:30 as usual. So it's June 3, it's Wednesday, 9:30. Solve the problems today, tomorrow, and if you have some questions, write on the Telegram channel. I'll try to answer your questions. That's all for today. Thank you for your attention and see you next time.
Goodbye, teacher.